Hi, this is the recording of the Excel tutorial or workshop for PUBP 741. In this first tutorial, I'll be going over some of the very basics of Excel, and then I will go through an example with cost-benefit analysis, so something more specific to what we need for the class. If you haven't worked with Excel before, this tutorial is probably the best place to start. All right, so the first thing we have to ask is, what is the spreadsheet and why is it useful? And basically, a spreadsheet is just a computer version of a ledger. An example of a ledger could be something as simple as the calculations that you did for the midterm. I asked you to calculate some present value formulas. Many of you set up a kind of timeline, which looks a lot like a ledger, and then you had to do some calculations with each element of that. Now, you could have done that just as easily in the Excel spreadsheet or any spreadsheet application. And honestly, both the way you did it on pen and paper and the way you would do it on Excel for those particular examples would probably take around the same time. Where Excel becomes a lot more powerful is where you can actually change some elements of the question without having to redo all of the work. And hopefully that will become clear over this and the next video. So the very basics, when you open Excel, you open a spreadsheet that looks something like this. There might be a little bit of different formatting. And essentially the spreadsheet is made up of columns. So I'm just clicking into the columns here. And those are identified by letters, and rows, which I'm clicking into, which are identified by numbers. At the intersection of a column and a row is a cell. So if I just click into any random one of these boxes here, an intersection of column B and row 3, we call this cell B3. We always put the column letter before the row number. Right? So if I click in here, I'm at cell C4 or A5. And you can always know what cell you're in by the cell window. Okay, so the placement of this cell window is going to be different for Windows and Mac operating system. But you can see that it actually tells you what the cell number is. Okay, A5, D5, C2. Okay, and that's how we're going to refer to cells. Now, what can you put in a cell? There's a lot of things you can put in a cell, and we'll split them into 3 different categories. You can put text or labels into a cell. The other thing you can put in is numbers or constants. And finally, the third element that you can put into a cell is a formula. And we'll go through each of those one by one. Okay, so for text or labels, right, you can kind of click into any cell. Right, so let's say I click into A2 here and just start typing, right? So I can type my name, right? And then press enter, which will take me to the next cell. I can type the name of this course, right? Sorry, I should make it caps. Right, I can type in any label. Right, and most of the time when you're typing in labels, you're trying to identify what elements are important in your spreadsheet. Okay, and we'll kind of come back to that in a little bit. What else can you type into a cell? So the other element that you can type into a cell is a constant or a number, right? So I can also type in numbers like the number 1,000 or the number 20,000. Right. All sorts of things that I could type in. I can type in 5%, right? And I would probably, instead of typing in 5, I would want to type in 0.05, right? Because that's what 5% means. There's all sorts of formatting things that will do it for you, but I'm trying to keep this as simple as we can. So just remember to type in numbers as they need to be for mathematical calculations. Right? You can type in any kind of number. I could type in a kind of classic present value question, right? So what is $100 2 years from now worth today? And you can assume that the interest rate is 5%. Not 54%, 5%. Okay. Now, so that was text. And what I'm going to do is just put in the information so that it's available to me when I want it. Right, so if I do something like this, right, so I'll put in, well, what is my interest rate? So I'm just putting in labels. I'll put the labels into the A column, so in A3, I've got the label, and then in B, I'm going to put in the actual number value. I know what my future value is. Future value is, of course, 100. And I know what my N is, or the number of years that have gone by. So that's 2 years have gone by. Right? And now I've got all the information that I'm going to need in order to do a present value calculation. Okay? So you can see how the labels or text is going to help me identify different elements of my problems, so that if I close this thing up, then I open it tomorrow, I'll have all the information readily available and very clear to anyone that opens the spreadsheet. All right, so the final element that is involved with cells, so you can input labels or text, numbers or constants. The final thing is formulas. So let's just go to a new sheet, clean sheet, and we'll come back to that information that I had just put in a little bit. The final thing you can put in is formulas. So let's just make sure we're all on the same page here. All right, so when you type in a formula to Excel, you're basically turning Excel into some kind of calculator. Right, so I can do something, a very simple question. So I can type in something very simple like, what is 2 plus 3? Right? And obviously we can all do this in our heads, but to show you how you would work a formula always starts with the equal sign. So I would put in equals and then just write 2 plus 3. And now when I press enter, Excel becomes my calculator. Right? I just pressed enter, and now in cell A4 it says the number 5. Now, the important part is noting that while it shows the number 5, there's a formula behind this number 5. And in order to know that there's a formula behind the number 5, I look into my cell window and it says, well, in A4, we've got the formula equals 2 plus 3. Okay, equals 2 plus 3. And what it'll actually show in A4 is the number 5. And we can make all sorts of more complicated formulas, right? Obviously, this would not be the most interesting formula. But anytime you need to use a formula, you're always doing equals. You know, you can do 7 cubed. So to do 7 cubed would be equals 7, and then this little triangle hat. Okay, that's over the 6. So 7 to the 3rd power. Okay, and it's going to show me 343. So 7 times 7 times 7 is 343. Okay. So a couple of things to keep in mind when you're using formulas in Excel. The first thing is the order of operations. So I don't know, sometime in elementary school, I think we learned the please excuse my dear Aunt Sally. Right. So the order of operations is how you're supposed to do mathematical calculations. And that is that you always do what's in parentheses first. Then you do exponents, multiplication and division, and then addition and subtraction. Okay. It sounds like a trivial thing, but Excel will read what you put in kind of literally. Right? So if I were to put in something like this, okay, equals 100 divided by 1 plus 0.05 squared. Okay, so there's a lot of things going on. There's division, there's exponents, and there's addition. Now, when I press this button, let's read what I've done in this formula. So in A7, we have the number 100.0025, and that's a result of the formula where it said equals 100 divided by 1, which is 100, plus 0.05 squared. So it did 0.05 times 0.05 and then added it to 100. And you get 100.0025. Now, if I wanted to actually do a present value calculation where I was taking 100 divided by 1.05 squared, I would need to be very careful that I put in the parentheses in the right spot. So I would have to do equals 100 divided by parentheses 1 plus 0.05, and everything in the parentheses now is going to be squared because I've closed the parentheses. And you see I get a very different answer. Right, so just the addition of parentheses around the 1 plus 0.05 element totally changes the answer. So if you do this wrong, right, if you don't put the order of operations correctly, then you will get a different answer. You'll get the wrong answer. Okay, now I didn't just choose these formulas randomly, right? So the present value calculation that we had done before, right? What is 100 2 years from now worth today? Assume R equals 0.05. So now I can figure out my present value. I'm going to do this in two ways. So I've got equals, well, 100 divided by 1.05 squared. So in order to make sure that I'm going to square 1.05 and not just 0.05, I'm going to put a parentheses, 1 plus 0.05 squared. Okay. Again, be very careful that you are squaring 1.05 and not just 0.05, and that's what the parentheses are going to help you do. Okay. Once you've got the idea of the formula down, and the idea that you have to make sure that that Excel is going to do the order of operations the way that you mean it to do, there's a couple of other elements of formulas that are going to be very key to using Excel, and that is using references rather than constants. So right now in the cell B7, I've got the answer to the question, what is $100 worth 2 years, what is $100 2 years from now worth today? I've got the answer to that question, but if I change that slightly, right, so what if I said, well, instead of an interest rate of 5%, I really mean an interest rate of 10%. Well, then I'd have to do everything again. I'd have to go equals 100 divided by parentheses 1 plus 0.1 squared. Right, and that's kind of annoying to have to do everything all over again. So something that you can do in Excel is instead of having to type in the numbers, you can actually reference other cells. So I can tell Excel add cell B3 to whatever is in cell C3. Right, which right now is nothing. So I could tell Excel equals B3 plus C3, and I'd get the answer 0.05. Okay. In our case, with present value, right, so we do the present value calculation with references. All right, so now let's do this, right? What I'm going to do is I'm going to do equals, and now instead of typing in 100 the way I had done just before, I'm going to say, well, I want you to take whatever is in cell B4, right, which right now is 100. So I'm just going to type in B4, okay. And I didn't make that blue. Excel has made that blue for me to tell me, oh, you mean the cell B4, whatever is in cell B4. Yep. I'm going to say, and divide that by 1 plus the interest rate that I've already told Excel is in B3. So type in B3, which is now shown in green. And I want to take that to the power, or the number of years, shown in B5. So I type in B5. Okay, now, of course, these two things are the same. Okay, these numbers are going to be the same because they're the same numbers are part of the calculation. But remember I said, what if I wanted to change the 5% to a 10%? Well, here's the nice thing. All I would have to do is go into my B3 cell, the cell that's delineating my interest rate, and type in, 10%. Now look what's happened. The present value calculation that I used with constants, that hasn't changed. But the present value that I used references has changed. Okay? Because it's just saying whatever is in B3, whatever is in cell B3, that's what you're going to use as the interest rate. As an aside, there is a present value formula built into Excel. There are a number of formulas built into Excel that can make life easier. I'll go over